And we're back. It's time to sport it out with Mr. Sport Out. Here we have some problems focused on work. Here is a very simple situation for that. Horizontal force with no friction. We want to find the work done by the tension force as it's pulling this block across the table, and we want to know its final velocity. So, work. If you know the force being applied and you know the distance over which it's working, and it is parallel to the displacement, you can use this expression right here, force times displacement. So both of these are given in the problem. Just remember, if we have the distance in centimeters, to turn it into meters. Then we want to find the final velocity. And to do this, let's use something called the work energy theorem. So this tells us that the net work on something is going to be equal to its change in kinetic energy. Change in kinetic energy would be kinetic energy final minus kinetic energy initial. So the net work is what we calculated above. The final kinetic energy would be 1/2 mv squared. Initial kinetic energy is 0. We're starting from rest. So then let's rearrange that a little bit. And then finally we arrive at this. And this would be our expression for the final velocity based on the work that was done on the box. Now, we could have used this, we could have solved this using kinematics. We could have taken the net force. We could have figured out the acceleration of the box based on the force, net force and its mass. That would have given us the acceleration, and then we knew the distance, so then we could have used a kinematics formula for that. However, work energy theorem, usually much simpler, much more direct, so that's what we need for this one.